Good morning, Kevin. Good morning, James.
Morning.
Okay.
Good
I just
morning.
like, good morning. I just like to check with you. Did you study before in math something called complex numbers?
Um, a little bit, not too much, not enough to
Okay.
help.
Oh, I see. Okay. Well, well, today we are going to review the concept of complex number, uh, because we are going to use it a lot in AC circuit, and you're going to use it in many subjects. So just I will just do it today. So feel free to stop me if you feel you don't understand any concept or any examples. I will focus on many numerical examples to make sure they can understand. So I will just start with the concept of complex number and how they started. And then we'll go for the application and the relationship between complex numbers and phasors. But okay, what's complex number? Well, first we have to know what's real number. You know, real number, it can have something like 1.345, whatever. That's you can have positive, you can have negative. All right. Uh, so these are real numbers that we deal with it every day. Okay. I don't want to. I don't like to go like irrational number, but just I want to say in general, real numbers. That's we know. But there's something else that was invented by mathematicians that solved a lot of problems. Like when I ask, what is the square root of 9? So square root of 9, I know everybody will say it's either positive 3 or negative 3, because we know that when you multiply positive 3 times positive 3, you get 9. And if you multiply negative 3 times negative 3, you get 9. So the square root of 9 is positive or negative 3. So in general, if you want to find the square root of a square, you say it's plus or positive or negative a. Okay, because we know that positive a times positive a is equal a square. Negative a is equal a square, and we are good with that. We don't have a problem. But if I ask uh, uh, what is the square root of negative 9? Well, some might say, okay, it's negative 3. No, it's not right. Because if you multiply negative 3 by negative 3, you'll get positive 9. So it's not equal to negative 9. So that was a problem faced the mathematician. How can you find something, But they invented something. We say, okay, we want to invent some kind of number, imaginary, and they call it J. And they said that J, if you square it, will be negative 1. You see, that's the starting. Said, okay, J square is equal to negative 1. That's great. So if I ask, what is the square root of negative 1? You say, okay, negative 1 means J square. So it means you're asking me about what is the square root of J square. Then you tell me is equal J. And if you want to check, you say J times J, it's equal J square, which is equal negative 1. So they invented J. So J actually equaled the square root of negative 1. Let's just say that's what this had. J is an imaginary number. The imaginary number, something uh, in the beginning, something that doesn't exist to imagine. But listen, it exists. Maybe that will be the first time to you, maybe heard before, but exists. How come it exists? And you are saying imagine number. That's what they said in the beginning. But when you look for J, actually, it's something, if you make the operation twice, J square will equal negative 1. Let me just refresh your memory. By the way, guys, can you see the screen? Is it clear for you or not? Or do you like to turn it to white?
I could see it. It's fine.
Great. Okay. So let me check just the attendance, because I'll close after 5 minutes. So because I don't like to have interruption. So where is the right? So let's go back. You see, that's why I like you guys to be on time. Thanks for Kevin and James to be on time. So I finished the attendance uh, quickly, and there will be like, because when I start teaching, it's just I get very absorbed, what I'm doing. So now I'm going to do something really interesting. Uh, you remember X and Y? So that's X and Y. You remember something called the unit circle? Okay, let me just make the unit circle. That's a circle. If you remember the unit circle, that's the x-axis, y-axis. You remember this point is positive 1, right? So if you rotate by negative 90 degree, you get J on y-axis. Oh, look at that. So J, it's an angle 90 degree. All right, let's agree about that. So J, let's write this unit circle. So the magnitude is equal 1 and the angle is equal 90 degree. Just let's write like that. So if you make one rotation, from this point, you rotate by a 90 degree, you reach J. What about if you make another 90 degree, you have J square, which is equal to what? Negative 1. You know that this point is negative 1. Yes, I know. I know you know that. You know that this is equal positive 1 and this equal negative 1. That's what you know. But now I am explaining to you how you got the negative 1. You are rotating by 180 degree, which means 90 and then 90. So J square is equal 1 angle 90 times 1 and angle 90. And listen, when you multiply number by number, you get number. 1 times 1 is equal 1. But when you multiply the angles, you do not multiply, you add them. You say 90 plus 90. So it equal 1 over 180, which is equal negative 1. So it's you can see it. What about if you have another rotation, another 90 degree? That would be 270. J squared, you will have J cube. What is J cube? J cube is equal J square times J. What is J squared? Negative 1. J, negative J. Look at that. So you have here J in the positive y axis, and you have minus J on the negative axis. It makes sense, right? Like when you have here 1 and you have here negative 1. Makes sense. And if you move now, now this is equal minus J, all right? And then you have another 90 degree. So you multiply another J. So multiply minus J times J. So you get minus J square minus, what is J square? Minus 1. What's minus 1? Positive 1. That's right. All right. So does it make sense? Makes sense. I don't want to elaborate more on that because when they found that they did many things, they made like alpha is 120 degree and then 120. So I don't want to get you confused, but just I want to tell you, Jay, I know you 11 math is equal square root of negative 1, but until you now, it means 90-degree rotation and solve everything. Great. So now we know.
So is the
Yes,
x-axis representing real numbers or are they still imaginary?
beautiful. X-axis is the real number because anytime you multiply, you find only a real number. So when you look for the x-axis and y-axis, let me just send you ask this question. Uh, let's say that x represent the real number. Y, for example, this is 1, this is J. Y represent imaginary number. We call it IN, imaginary number. So this is one real number, and this is a negative side of x-axis, and this is a negative side of the imaginary axis. Okay, and of course you can have 1, 2, 3, 4, 5, 6, and anything like that. So let's just have an example of a what number I want to call now. What if you have a number consists of real part and imaginary part? So what you call it? Interesting. I'm going to say it now. Let's say that you have, uh, okay, I'd like to have just a, let's say that you have number, and this number we're going to call it C is equal 3 plus J4. So this is the real part. Okay, just let me just make it simple. That's the real part, and that's the imaginary part. So the whole thing, if you have a number, consists of two parts. One is real and the other is imaginary. We call this number complex because, you know, I don't like this name because it just means it's complicated, but it's not complicated. Actually, it's really easy. But just this is the way that they call it, complex number. Complex number consists of two parts, real and imaginary. How we represent it? Well, x-axis and y-axis. Let's just do that. That's x-axis. That's y-axis. One, two, three. So that's the real part. Three, and then you have one, two, three, four, J4. So the number you go up to here, up here. So this is the number. So this is C, which is equal to 3 plus J4. That's a complex number. Interesting. So that's geometric representation of a complex number, right? It's the same thing that you did before, but we call the y imaginary axis. So that's 3 plus J4. We call this rectangular form. So just let's learn the terminology. So rectangle form will be like C equal to 3 plus J4. In general, if we want to write in general, so let's write A plus JB. In this case, we have A is equal 3 and B is equal 4. Right? That's rectangular form. There is another form called polar form. Polar form. Polar form, what does mean polar form? It means you want to find the length of the vector and the angle. So let's just choose different color here. So I hope that we can see that. If you connect the origin by this one, all right. So it's direct from here. So the length of this one, okay, you can make like a triangle here, right? And this is equal 3, and this is equal 4. So the length of this will be uh, the magnitude C is equal A square plus B square square root. A square is equal to B square plus 4 square. That will be equal to 5. So the length is equal 5. So the length is equal 5. You got to know the angle, the direction from the positive x-axis and in the direction of the anti-clockwise direction. We call it theta. So what is theta? How you find theta? You find theta by finding the arctan of the imaginary part B divided by A. In this case, you will have 10 minus 1, 4 over 3. And just I will use my calculator here and trying to find arctan 4 over 3, and I use degrees here. So I got 53.1. So 53.1 degrees. So now I know the uh, uh, the length of this line, which is equal 5, and the angle is equal to 3. So how you represent this complex number in polar form? You write the magnitude. So say C is equal the magnitude on angle theta. All right. So in this case, you will say C is equal to, the magnitude is equal 5, and the angle is equal 53.1 degree. That's the representation in polar form for the same example I did. And you got to remember this angle theta always measured from the positive axis, x-axis, and in the direction of what? Anti or clockwise, counterclockwise sense, right? That's the polar. Oh, all right. Simple. So you should be able now to convert from rectangular form to polar form, from polar form to rectangular form. You see me what I mean? You just, just a second, I want to check something here. Do I have the recorder on? Sometimes not. Oh yes. Okay. I want to make sure that you have access to the recorder, because I'm sure that you will need to watch again. So let's have another example for something given. Example. Let's say that a complex number given like 10 on angle negative 60. All right. Convert to a rectangular form, or express C in rectangular form. All right. Let's see how we do that. Well, so we say that C expressed now as a magnitude and angle theta. Any angle theta can be expressed as cosine theta plus j sine theta. Then maybe sometimes you'll ask me why. Okay, I'll tell you why. If you remember in math, theta can be expressed like that. So this is the way to represent an angle in exponential form. If you remember, we call it Euler form, all right? So I'm using this a lot, just making like that. But I'd like to tell you how it comes from. That's EJ theta. And EJ theta, Euler form, EJ theta can be expressed as cosine theta plus j sine theta. This is the way that we're going to represent. So let me write again. If you have complex number expressed in polar form that can be expressed as, the angle could be EJ theta, and so that's the magnitude C, and theta will be resolved into a complex number, cosine theta plus j sine theta. So if you multiply, you have C magnitude times cosine theta plus j C magnitude times sine theta. So I distribute C multiplied one time by cosine, one time by sine. It's and as you know, C is equal A plus JB. That's what we started, right? So if you compare, that's your A and that's your B. So your A is equal to C cosine theta, and B is equal the magnitude C times sine theta. Let me now go to the problem that we have. We have C equal 10 on angle negative 60. The problem is given C equal 10 on angle negative 60. So if you do the same thing, you will say 10 cosine negative 60 plus j sine negative 60 equal 10 cosine negative 60. We know before that cosine, should know that cosine negative theta, it's the same as cosine theta. All right, we don't have problem with that. So I would say it's equal 10 cosine 60. But for sine, you get the negative out. So we have sine negative theta is equal negative sine theta. All right. I know I had this before, but it's in our way, so just to review it. By the way, all this will be like a PDF file that will be uploaded as usual. So don't worry about writing anything. Just pay attention and answer as much as you can. So this is your A and this is your B with the negative. No, just let me go another step. We know that C is equal A plus JB. So your A is equal 10 cosine 60 and B is equal negative 10 sine 60. 10 cosine 60, I will go ahead and do it in my calculator. 10 sine cosine, and you can do it to check if I did any mistake or something. That will be equal 5, and that will be equal 10 sine 60, and decimal will be minus 8.66. So now the number, the common number C equal A plus JB, you can write 5 minus J 8.66. So I convert. So as you see from the step here, what we did, negative 60 considers cosine plus J sine. And be careful about the sign. And you simplify till you get in the end real and imaginary number. That will be your A and B. So that will be the answer. This is, by the way, not this is point, right? So that's the equivalent of. Now we did the example how to convert from rectangular to polar, how to convert from polar to that's okay, great. Uh, what we want to do now, we want to do some kind of operation. Now we know what's complex number. Complex number consists of two parts, real and imaginary. Now when we use it and our application, we need to add, to subtract, to divide, multiply. So we want to do some basic mathematical operations. So now we're going to do mathematical operation of complex number. All right. Let's let's start. Before we start, we got to have to define. Let's given two complex number A equal to 2 plus J1 and B equal to 1 plus J3. So we want to find the sum. So we want to add A to B, A plus B. So we'll say 2 plus J plus 1 plus J3. You add the real. So you have 2 plus 1, that's the real. You see, it never makes you have to add real to real. Imagine it's plus J, take it to common factor, 1 plus 3. So you got 3 plus J4. So that will be the answer for A plus B. So you add real to real, imagine to imagine. Let's subtract A minus B. So we'll have 2 plus J, that's A, minus B, 1 plus J3. Will be equal to 2 plus J minus 1 minus J3. Because this negative, you multiply negative 1, negative J3, you get this one. Then you add the real, that's the real negative 2 and negative 1 will be have 1. And then measure you have J and minus J3, you have minus J2. So easy, the addition and subtraction, right? Okay, let's have now something else. I want to multiply these two numbers and divide it, all right? So I'll multiply it first as it is. A times B. A is equal to plus J times B, which is equal 1 plus J3. And the second, Okay, guys. Next time, just like to have the attendance finished in the first 10 minutes because you see, as you see, it interrupt every time somebody comes interrupt us. So next time, just try to be the first 5 minutes. Okay, so because the problem after I finish, then somebody come and send me email. I attended, but they didn't record me because maybe it's late. I got involved, absorbed in the lecture. So please just try to do your best to be early. Hope that 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, I'm done. So I will not go back again. Now let's go back. We are going to multiply these two numbers. So how you multiply? Easy. Uh, you multiply the first. I'd like to do it in this way. 2 plus j, 1 plus j, 3. You do it like that. 1 times 2 is equal to, I'm just focusing on this one. And then multiply with the top. 1 times 2, 1 plus j. So 1 uh, times 2 is 2, 1 plus j is j. And then the second one, j plus 3 times 2, that will be equal j 6. 2 times 2. And then we have plus j squared 3. Okay. So I have 2 plus j. And by the way, no, there's just material. You can do it in this way and you add, but you can do also like in the way that I'm going to show you now. You can say 2 times 1 and then 2 times j3. So you have 2 plus j6. And then j times 1, j times j3. So we have j and 1 plus j squared 3. You get the same thing, right? So if you don't like to do it in this way, just you can do it in this way, in the same line, same time. There's something there are many different ways. Now 2 plus j6 plus j, and j squared is equal to -1. So -1 times 3, -3 equal. Add the real number 2 and -3, we have -1. And j6 plus j will be plus j6. All right. So that will be the multiplication. What about division? Division. A divided by b. A divided by a is equal 2 plus j, and b is equal to 1 plus j3. To do that, we do something interesting. You write it back again as this started, and then multiply by something called conjugate. Conjugate. What does it mean, conjugate? Okay, let me just show you here. B is equal 1 plus j3. Its conjugate. We don't do it like that. B star, conjugate. You write it back again, but by changing the sign of the imaginary part. So B1 minus J3. You flip the sign of the imaginary part. If it's positive, make it negative, negative, make it positive. So if you have something like that, in this example, you want to have A divided by B. You will say A, B, multiply by the conjugate of B, the one in the bottom, not in the top. So you see multiply by B conjugate here. So you didn't just change anything, right? Because you multiply both by the same thing. Why I'm doing that? Let me just write A times B conjugate. What is in the bottom? To show you what the result on the bottom, let's just delay it a little bit to show you here how we can get. When you have B and multiply by its conjugate, like if you say B equal A plus JB, what is the conjugate of B? It's A minus JB. The conjugate, that's the meaning of conjugate. When you multiply any number by its multiplication by its conjugate, let's see what's happening. A plus JB times A minus JB. Let's see the result. Just let's uh, wait for this guy a little bit because we're going to deduce a relationship. Now multiply a times a and a times minus g. So you have a squared and minus j ab. All right, that's a little bit close to it. And then I will start to multiply jb by a, jb by minus jb. All right. So what you get jb times a will be plus jba and plus j minus j squared b squared. Great. Let's now, I have a squared. Oh, I just saw something interesting. Now, minus JEB and plus JEB will cancel, right? So what's left? A squared. And what minus J squared B squared equal A squared minus what is J squared? We know that J squared is equal -1. We know that in the beginning also. So minus and J squared minus with plus. Ah, that's interesting. So what we found out that if you multiply any complex number by its conjugate, you get the square of the real, the square of the measure, and you add it. Hmm. So b times b, that will get like a square plus b square. Let me just elaborate more on that because it's something interesting. It's still very interesting to find. What is a plus b? We know that b it's equal a plus jb originally that we start. If I ask you about the magnitude of b, what you're going to say? Say square the real, square the imaginary, add them, find the square root. What about if you want to find this square? You get the square root. You get rid of the square root, so you have a squared plus b squared. It's the same result you got here. So actually, the magnitude, see division just open for us. So actually, the magnitude of complex number, if you square, it will be equal a squared plus b squared, which is equal to if you multiply b by its conjugate. That's what we got. Right? So when you divide, now I go back to my example. If you divide two complex number, so you will have uh, a times b conjugate and b times b conjugate that you can write it like, okay. Why I'm doing that? I am doing that because when I was dividing, how can you divide this number 2 plus j over 1 plus j3? I don't know how to divide. So I want to convert this to real number. Because if I was dividing 2 plus j over any real number, it would be easy. I divide 2 by a number, j by a number. But now I have 2. I have complex number. So I couldn't. So all my goal, I want to make the bottom here just one number, one real number. Imagine just one number, not 2. So what I did, I tried to figure out how I get rid of this thing. So I said, okay, I'll multiply by the conjugate. That was my idea. So when I multiply by a conjugate, I'll get something else. But I was showing you how you get rid of it. So I didn't finish yet. I'm just telling you about the strategy. I want to get only one number on the bottom because I don't know how to make this division. Never faced something like that. So now the problem is originally dividing 2 plus j over 1 plus j3. I don't like that. I don't like the bottom bar. So I said I want to change the whole thing to one number. So I multiply by the conjugate. As we know from previous, when you have this is like what is that in the bottom? That's b times b equal. When you multiply any number by the conjugate, you get the real, you get the imaginary, square them, add them. So when you say b is equal to 1 plus j3, So its conjugate will be equal to 1 minus j3. When you multiply, you don't have to think about it. I just want to do it fast. What's the real number? What's A? 1. What's B? 3. To me, negative 3. No, I'm talking about B, right? So square A is equal A squared plus B squared, as we know. So it'd be equal 1 square plus 3 square. That's equal 1 plus 9 is equal 10. So now the bottom part, when you multiply 1 plus j3 times 1 minus j3, now I have a nice number, just 10. So what I'm going to do, I would say A plus B equal. And now look in the last thing here. I have 2 plus j multiplied by 1 minus j3. And at the bottom now, 1 plus j3 times 1 minus j3, that will equal 10. Now I feel optimistic I can solve it. I am dividing only by one number. At the top part, I don't have any problem because I know how to multiply. All right. The multiplication at the top is easy. Multiply 2 times 1 is equal to 2 times negative j3 negative j6 plus j times 1 is j minus j square 3. And then I simplify. But I just have in the bottom one number. So I have 2, okay, 2 minus j6 plus j, and then again j square minus 1 minus the minus positive 3. Simplified more. I'm showing in steps, detailed steps, but you can do it in your head quickly, but I don't like to do that now. 2 plus 3 is equal 5 minus j6 plus this minus j5. Did I do any mistake here? Let me just review. 2 times 1 is equal to 2 times negative j3 will be negative j6. Now I'll take this one. J times 1 is equal j. J times minus j squared times 3. That's right. 2, so 2 minus j6 j minus j b plus 3. 2 plus 3 is equal 5 minus j minus. That's right. So now if you continue, that's easy. I will say it's equal 5 over 10 minus j 5 over 10. See, now I can do the division, but in the beginning, when you start, it's when you look at this one, how we divide this? That's a big mess. Now just divide by a number, that'd be great. And then I distribute the division. That will equal 0.5 minus j point. So that would be the answer if you divided A. So the concept when you divide two numbers, what you're supposed to do, just use the conjugate. All right. But I showed you how to do that, how to multiply and divide using rectangular form. But let me tell you about the practical approach. Practical approach. If you want to add or subtract, my advice to you, use rectangular form. If you want to multiply or divide, don't use rectangle form, use polar. Really? Yes. Why? Because it's much easier when you multiply or divide, use a polar form. Can you show us example how you multiply and divide using polar form? Yes, sure. Let me show you now the big difference. But why did you show us how to multiply and divide? Because sometimes you'll face it, sometimes, few times. But if when you have a choice, convert from rectangular to polar and do what I'm going to do now. Let's now say that if A was given in a polar form, different numbers. Let's say it's equal 3 and angle 35 degrees. And let's say B is equal to an angle negative 20. I want to multiply and divide. Well, when you have now it's expressed in this one, A magnitude on angle theta 1. All right. Or let me just write it in a different way. If you have two numbers, T1 complex number has a magnitude and has an angle, And let's say you have another number, complex number C2, has a magnitude C2 and angle theta 2. And you want to multiply C1 times C2. What you'll do? Multiply the magnitude, add the angle. Okay. Why? Because when you multiply, you will say that the first one times the second one. The first one, you multiply the magnitude, C1 times C2, and the angle, when you said before, when you multiply the angle and you add it, theta 1 plus theta 2. That will be C1 times C2. So if you look for our example here, AB, if you want to multiply AB, A is equal 3 and angle 35 degrees. B equal 2 and angle negative 20. So multiply the magnitude. 3 times 2 is equal 6, and the angle you add 35 minus 20. That will be equal 6, and the angle will be equal 15. And if you want to convert it to rectangular, you can do that. You know how to do it, but it's easier. See, it's very obvious which one is easier. You multiply using the polar or the rectangular form that we did before. Oh, yeah, of course, this is easier. The division is also, it will show you now much easier. Let me divide the same two numbers. But let me give you the rule. If you are dividing two complex numbers C1 by C2, the first one has a magnitude C1, angle theta 1. Second one has a magnitude C2. It looks like E. Why? You have magnitude C2 and angle theta 2. You divide the magnitude, that's normal, but the angle, this angle go on the top, be theta 1 minus theta 2. Theta 1 minus theta 2. The top minus the bottom. In our example, A over B, A is equal to 3 and the angle 35 degree, and B is equal to 2 and the angle negative 20 degree. When you do the division, you'll have 3 over 2. That will be 1.5. Let me just do it in steps. So you have 3 over 2, the magnitude, and the angle, the top minus the bottom. Be careful about the sign. So you have 3 over 2, and the angle will be 35 plus 20 will be 55 degree. Convert to the decimals, you have 1.5 angle 55 degree. It doesn't look 55. That would be that. So which one is easier? Using Cartesian rectangular, sometimes we call rectangular Cartesian. Rectangular form or polar form? Of course, polar form. So somebody said, okay, but the problem that you did before in rectangular form was given rectangular form. Does it mean that I got to, if the problem was given like that? So should I convert it first to, yes, go ahead, convert it to polar form and then work with it. By the way, if you use MATLAB, it will be easy. I will give you some examples in the put canvas for using MATLAB. There are some functions to work with this easily in 1 second. Is it important to know? Of course, there are tools you're going to use it. Why not? So if you'd like to make it easy, but you got to understand how it's done first. Well, that's great. So now we know how to multiply, divide, add, and do all this business. All right. And even we learn the conjugate. And the conjugate means that we change the sign. I'd like for the conjugate, I know I explained it, but I'd like to represent it on the graphical representation for conjugate of complex numbers. So let's say I want now to show you how to do the complex conjugate. just like to show you how we represent it on X and Y. So if you have A equal to, let's say, 3 plus J4. So if you go to X and Y, that's X, that's Y. So you have 1, 2, 3, and you go up for 1, 2, 3, 4, that corresponding to J4. So this is the point that you have that represents 3 plus J4. All right. So, and if you want to find the conjugate, it will be 3 minus J4. So you go just on the 1, 2, 3, 4. You just make this axis, okay? So you have minus J4. So this is the conjugate, 3 minus J4. So the complex number, its reflection on x-axis, see, by changing. All right. If you do in using the other form, so let me just write. So you have, if A is equal A plus JB, so the conjugate is equal to A minus JB. Okay, I just want you to understand that. Now you will tell me, but you told us in rectangular form. What about polar form? All right. Polar form, let's say that A is given as a magnitude A, angle theta. So if you do that, let me just use another color. Yes, this is the polar form. 5, and angle, I think we did before 53.1. Let me just refresh my memory and find the arctan just to make sure I put the right number. 4 over 3. That give me the angle. We did its example for 53.1. So if you have a complex number A represented by A magnitude angle theta, the conjugate will be A angle negative theta. Why? Well, look at that. Look at the graph. I like graph representation. If you connect this line here, you'll find the magnitude is the same, it's 5, but the angle now is negative, right? That's, you are moving in the clockwise direction, be negative, right? So in this representation, if you say that A is equal to magnitude 5 in angle 53.1, the conjugate will be equal 5 and the angle negative 53.1. That is a conjugate, right? So now I show you how to present. We know, we proved before, if you want to multiply A times A conjugate, I'm going to use the this form, the polar. A is equal A magnitude on angle theta times the conjugate will be A magnitude angle negative theta. You know, when you multiply, A times A will be A squared, and theta, you add the theta, will be 0. So it will be the magnitude squared. That's what I did. We did before. Tell me, what does mean magnitude? Well, if I ask you what is the magnitude, what is the magnitude of A? Square 3, square 4, right? A squared plus B squared. So you can say now A times A conjugate is equal. The magnitude of, of the complex number, or in different way, that's the magnitude if it's given in rectangular form. All right. So it's equal to the magnitude square. That's all. So now, I mean, I did one page complex conjugate. We did that before, I know, but just it's better to have it in a separate page here so you would know what you're supposed to do about. Now, just let's I give you something in your class practice today to do, something like I will show you, but don't be shocked or scared. Reduce the following or simplify the following. Let's simplify the following. Find the value. Find the final value. Or evaluate the next expression. A is equal to 6 plus J5 plus 3 minus J4 times 10 angle 40 divided by, I'm not going to solve this one because that's very similar to the class practice, but just I'm going to ask you now what you'll do because I want to move to application of the circuit. 30 and 53.1 degrees. Look at that. Quite an explanation. Now let's just ask, what do you think the first step you're going to do? Anybody want to volunteer to answer this question?
Do you have to multiply the conjugate, the bottom?
Multiply the conjugate. Let's just go and check the
Well, I
bottom.
assume you got to convert it to
Yes.
6 plus j or whatever it's going to be, and then you multiply it.
That's 6 plus 30. So there is kind of addition here. And we agree that addition, it's better to use in rectangular form or polar form when you add.
Rectangle.
Exactly right. So the first thing, I'm not going to do the whole solution, but just I'm going to show you the first step and you guys do it. 6 plus 30, 53.1. We'll find this value first by converting this, converted to rectangle. That's right. And once you convert to rectangle, it'd be easy to add it to 6. But in the end, you'll find that the result will be rectangle, right? So let me, before I just to write the technique of this problem, the strategy how to solve it. Let's just call names like this is, we call it A, right? Let me change the name. I'll call this C, and A will be 6 plus J5, B 3 minus J4, C 10 angle 40, D equals 6, 7, 7, sorry, E, the other number 30 on angle 53.1. So what you are saying is right. I want to go in the bottom to add 6 to 30. I want to add D to E, right? So let me write the expression. C is equal A plus B times C over D times E. That's the expression, okay? Just I mean, so we can have the same language. So what you're saying, you want to multiply D times E. I'm sorry, that's addition. Right. So you want to add D to E, but they have different way of expression. So E, it's in polar. First, you have to convert to rectangle. That's right. And after you convert to rectangle, you're going to add them. You get the result in rectangle, right? But remember, in the end of the day, you are going to divide BC over DE, right? So in the end, D plus E, this addition here, you have to convert to rectangle, you're right. But after you do that, you have the result will be in rectangle. But then that's the result. Let me just, the result will be in rectangle. But in the end of the day, you're going to divide. So it's better to convert it in the end in polar. So when you are adding rectangle. But because in the end, they are going to divide BC by D plus E, so D plus E should be in polar because division multiplication should be in polar. Now, if you go to B times C, B times C, B is rectangle, C is polar. And we know when you multiply use polar. So you got to convert B to polar. So after that, B will be converted from a rectangle to polar. That's the first thing. And after that, when you multiply B times C, you get polar. Good. That's good. And when you find B times C in polar, and B and C will be polar. D plus E polar, you divide. That's good. That's no problem. When you divide, what you get to be polar. So B times C over D plus E, the result in polar. But you want to add the result, this one, to A. And you know, when you add, it should be rectangular. So after you divide, you multiply and divide will be in polar, convert the result to what? Rectangle. And then in the end, you will add A. A is given in rectangle. That's good. Just add. So I will leave this for class practice to do it today. Right? And we explain already the technique how you do it. So to make sure that you are guys following me. Now I'd like to go because I have only like about 15 minutes. I want to make sure how can we use the complex number in circuit or in the electric engineering in general. Well, first of all, in electric circuit, we are working with AC and AC. We said before, we are dealing with sinusoidal waveform. So how can you deal with sinusoidal waveform? As we said previously, it's better to use phasor. So if you have like a voltage source, let's say that you have voltage source, and voltage source AC will represent like that, and we give it polarity too. So let's say a positive, negative, and we give it a symbol that let's call E of t. And E of t, let's say that expressed like that: maximum voltage, we call it EM, maximum voltage, sine omega t plus theta. We said last time how you represent this graphically, and it means plus theta, it's advanced by theta. All right, advanced by theta. So for example, let's get numerical number. What about if you have 200, if E of t, numerical number, we have 200 maximum sine omega t, I don't care about the frequency now, omega t plus 40 degrees. So what does it mean? It means if you sketch sine wave, and just let's make nice sine wave. That's not. First, I have to define the number, the dot. That's one, two, three. I like it two, 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 two. Right. And this maximum. No, that's tight. Stop. Make three. I wanna make understand what that's. One, two, three. One, two, three. So that's the maximum. That is 0. And that's one, two, three. That's the minimum. One, two, three. That's the 0. And one, two, three. That's again the maximum. All right. Now I can go and let my left hand. All right. So that's a sine wave. Well, it's advanced by uh, 40 degrees. Means it start by 40 degrees. So it will not start here. This is not the 0. The 0 will be 40 degrees. So I can put the axis here. So it starts from negative 40 degrees. It starts ahead. That's how you express this one. We know that. And the maximum is equal to 100. The minimum is negative 200. But we agreed last time that this will be expressed as a phasor. And what does mean phasor? It's if we have the real axis here that we always measure from, and this is the imagine now. Look at that. So the phasor This is the real, all right? And there's the imaginary. How we do the phasor? You remember last time we said that, okay, the phasor representation will be E. We make it capital letters all. You got to know that. If you want to represent that's the instantaneous representation, instantaneous value of the voltage. But to represent as a phasor, say E. In the textbook, you'll find that E is bold. I make arrow here because I can do bold here. Equal the magnitude without anything in the top. I know this only magnitude. And the angle is 40 degrees. And this is the unit voltage. This is phasor representation. Phasor representation. Mathematically, that's the phasor representation. Easier than every time I just having this waveform to sketch. No, just how you sketch this phasor. We did it last time also. The magnitude in our the magnitude here 200, and the angle is 40. So you make angle 40 degree, and you make a line with an arrow by magnitude equal to 100. So this is the phasor representation of the voltage. So it's 240 degree on angle volt. That's the way that in the box here, and that's the way of representation. You make a vector is equal to 200, and the angle is 40 degree positive because it's advanced. All right, and that's the phasor representation using graphical representation. Okay, so that's the way that we did last time. But what is happening now? I'm showing you that the real part here, the positive, and the imaginary part, the vertical, and this one, 200 over 40, that's the representation of the phasor diagram, right? And now you can add voltage in series or anything like that, and I'm going to show you. Like now, let me show you. If you have two voltage source, all right, and they are connected in series. Let's say that this is the E1, and let's say this E1 connect in series. So how you, this is instantaneous. If you look for the, let's say that that's the equivalent voltage across the source. That's equal to V. So you can write, say, V of T is equal to E1 of T plus E2 of T. But we are not dealing with instantaneous values because it's a kind of a puzzle. It's not easy mathematical. We like to use phasor representation because we are not going to draw that. We are not going to write 200 sine omega t plus 40. It's just puzzle. It's not easy. So how can I deal with it in a phasor diagram? Okay, represent this by phasor diagram. You say phasor representation. We have two voltage, and they are connected in series. Instead of writing that E is like E capital 1 phasor, E capital 2 phasor, and the voltage V, not of time, of course. Now we are just not in time, we are going in frequency. So the phasor of the voltage is equal to the sum of the phasor E1 plus E2. So that's the way we're going to do it. This is okay. Can you give us just some kind of numerical example just to can feel it? Yes, of course. Let's say that E1 as instantaneous voltage was giving 10 sine omega t. And let's say that the second voltage E of t is equal to 15 sine omega t, make it different, plus 60 degrees. All right. So I want to find the total voltage. You are connecting series. So the total voltage, you will know but in time, if you make it in time, continuous values, which is we don't refer, that will be E1 of t plus E2 of t. I'm not going to do it because it will be, if I write for you, it will not like it. I will say 10 sine omega t plus 15 sine omega t plus 60. I'm not going to waste my time, and I will show I can do it. I will use trigonometry. I will just sine omega t plus 60 be sine, cosine, cosine, sine, the trick. And then you start adding the sine. You will spend like 1 hour. All right. But phasor, it will be much easier. So I convert E1 and E2 to phasor. So I'll say E1 phasor equal the magnitude 10, no phase shift on angle 0, because just it's sine omega t, there is no shift. Now I'll go for E2 is equal, that's E2, that 15 magnitude and the shift 60 plus. So the magnitude is equal 15 and it's plus 60 will be 60. Nice. Now I want to add them. So I'll say the total voltage to add them. All right. I will write V. We'll call it V. All right. Call it V. So I see V phasor is equal E1 plus E2. E1 is equal 10 angle 0 plus 15 angle 60. What did we say when we are adding two complex numbers? It's better to use polar or rectangular. It's better to use a rectangle, right? So you will have 10 cosine 0 plus j sine 0. That's the angle, right? Plus 15, the second one. That's 15 angle 60. So you'll have 15. And 60 will be cosine 60 plus j sine 60. So on your calculator, 10 times cosine will be 10 plus j0. That's the first one. Plus 15 cosine 60. I'll do it like I'll multiply 15 times cosine 60 to find the real number. So 15 times cosine 60, that will be equal to 7.5 plus j 15 times sine 60. That will be equal to 13. All right. Now I add real to real. 10 plus 7.5 will be 17.5 plus j 15. So that will be the voltage in phasor. But I'd like to return it back to polar. So how to return back to polar? You find the magnitude. So the magnitude of the voltage will be 17.5 square, 15 square root. That will give 17.5 square plus 13 square. And then I'll find the square root of the result. You got to check the answer. So that will be 21.8 voltage. That's the magnitude. I want to find the angle. How you find the angle? 10 minus 1, the imaginary on the real. So theta of the voltage will be equal 10 minus 1, 13 divided by 17.5. So my shift 10, 13 divided by 17.5. That will give 36.6 degree, right? That's the angle. So you can say in the end that the phasor diagram or the phasor result of the voltage will be equal magnitude is equal 21.8 and the angle 36.6 as a phasor. Excuse me. Okay. So, but you thought maybe somebody will say, okay, that's good. You got the answer in phasor, but I'd like to how I written in sine or cosine. Okay. You return it back, say B of t is equal to 21.8, the magnitude, sine, the same frequency, omega t, plus 36.6. Here you go. Because the answer should be as given in the question. So this is the answer. But using phasors, it made it easier. for me to find the that's how you add. And the same thing, if you have anything like multiplying, now let's say that you have a circuit now, a resistant. I'll show you how we use it. You have a resistant. Okay, guys, just a second. Okay, I'm sorry, guys, because I just got to cough. Anyway, so let's just finish the example. So if you have a voltage source that's E of t, and you have a resistant, and you want to find the current, for example. So, and let's say that E of t is equal to, let's say you have 100 sine omega t. All right, and you have resistance equal to 5 ohm. Find the current I of t. So I will solve this one using the phasor. All right. First of all, if you are going to use that's a very easy example, but just showing you how to use the phasor in the circuit. If you want to say that the current is equal the voltage divided by the resistance, which is equal to 100 sine omega t divided by 5 ohm, that will be equal to 20 sine omega t. That's one solution. It's easy for resistance, but when we get to the inductor and capacitor, will be different. In phasor, you will say that the voltage E equal to 100 and the shift is 0 volts. The resistance is equal to 5 ohm. The resistance is equal 5 ohm. This example. So the current phasor, you just divide by Ohm's law, E divided by R. It will have 100 over R 5 ohm. You'll get 20 on angle 0 amp. So you can now convert it. You say I of t is equal 20 because you got an angle 0 sine omega t. So that's how we do that. It's easy for a distance, but when we work with inductor, capacitor will be there. So guys, I will stop here. And if you have any questions, I'm going to upload the class practice for you today, work on it, and do it in the end of the day. And already you explain how the technique to solve it. Do you have any question?
Um, Unrelated to this, but
Go ahead. Go ahead.
yeah, when the midterm, I think it was question 16, there was only one option for an answer.
Mhm.
It was a multiple choice, and there was only one option, and I didn't know
I
that
see.
was the
Okay.
correct answer or not.
Oh, okay. I would check this one.
And then
Anyway, yes.
one other for
Mhm.
the project, I used the code you gave us for MATLAB, and for
Mhm.
some reason, my
Mhm.
second graph
Mhm.
is just a straight line and a 0, and I don't know what that means. And no matter what I change, it won't change.
Make sure that when you take the steps be small enough. The steps when you increasing or decreasing the data that you want to sketch, make sure that the increment is small, because if you have big increment, maybe it will jump up. But
What
yes.
what value in the code do we use for the increment? Because I'm still new to it, so I'm trying to figure out how I implement my numbers into the code.
Okay. You see, you look for your numbers and take it like the increment that you are using. It should be, the steps should be very small compared to the number that you're using. For example, if you are using numbers from 0 up to 100, all right, and you want to sketch it If you take the step 50, you'll find you get 2 points. But if you have from 0 to 100 and you want to make it a good thing, so you say, okay, I'm going this 100 points, I'm going to make the discrement like over, like say 1,000 points. So you say 100 is the value divided by 1,000, so the increment will be 0.1. All right. So it depends on the values, or the range of the values you want to sketch. So because it's different from person to person. If you have a number and you say how many points I want to sketch, how many points? 2 points, 3 points, 4 points. Of course, when you have every time you have more points, uh, the curve will be smooth and it will look like a smooth curve. But when you take small number of points, so it will look like piecewise, like some segments of lines connected. And if you have very, very few, it will look like a straight line. So this is one point you have to be careful about. The second point, that you make sure that you never divide it by zero. So always when you do write the program, make sure that if you make any division, you make if statement in the program, like if is equal zero, then you try to avoid this by making zero something like not zero, not calculate this point or make it like 0.1. Because if you divide anything by zero by infinity, you'll be shooting up. All right. So it depends on the equation that you're using. It depends on the range of the number you're using. So it will guide you to do the increment. So the program that I send, if you look at the numbers I'm using and the range of I'm using, check the increment how I choose it. Check the relationship between the increment and between the range of numbers that you are using to program, to make your program. That's important.
Yeah, I'm still just caught up on the code. Like I look at it and I change numbers, and no matter I can't figure out what.
Okay, I'll tell you about something. You just copy the program that I did, run it, change the numbers, try to make change the numbers like close to your number, see what's happening, and then how you can change the increment. Because I think if you copy the program and run it and see the result, and you start to make some change, you get feeling which one that you should change. I think the program that I sent, it has also did I also send the result of the program or only the program?
You sent the results,
Okay.
but
The,
even though I copy and paste it, I get a different result. So
oh, uh, that's strange. Even the same, use the same number, the same program that I sent, and you get different results.
yes, the letter for letter, number for
Oh,
number, the second
okay.
graph is zeroed out.
Did you copy everything, even the statement in the top, like clear all, CLF, and all the things? Because that's a big problem, you know. If you don't like clear all and CLF, it means that every time you're running the program, you are keeping in the memory of the computer all your results. So when you run it again, it will take these numbers. So make sure you have this statement. They are not like fancy statement. No, they are really important. Clear all, CLF, CLC. You got to make it in the beginning of each program.
Yeah, I copied everything letter
Everything,
for letter, and
everything, and you still, if you copy the program I send by the numbers, by everything, and you run it, you don't get the same result I sent.
no.
You don't get it. So there's something I'm sure that I don't know. I will send the M file, so you don't have to copy and paste, because maybe when you copy and paste, when you copy actually the program from Word file to MATLAB, it doesn't come completely the same thing. I What does it mean? It means the MATLAB will not read the character as it is in the MATLAB file. So let me just send me an email to remind me to send the M file, so you can copy, not copy, just take it as M file. Other thing, that because I don't want you to type, waste your time. Because if you type, I'm sure you get the same result. But sometimes when you copy from file to another, the character that you copy to the MATLAB, it doesn't read it as it is, differently. I observed that one time I made a copy of my own program in MATLAB. It didn't work. It didn't work, give me error. Did you get any error, by the way, or not?
No, I don't think I
You
have
don't
an error.
get you didn't get any error. Strange. Okay, let me send M5 first, because if you copy the same program, doesn't work. So I want to make sure that you don't have problem in the MATLAB itself, and I don't think that you have problem in MATLAB. Just I will send you the M5 first and run it in your PC and see what you get. You don't have to
Okay.
copy. You take it, you just download it, save it in your laptop, and run it and see what's happening. So if it run, great. So you can just write over.
Sounds good. Thank you.
Okay, but please send me email to remember that, because I have many things, so I'm afraid to forget.
Okay.
Any question? Any more question? Okay, I will upload the PDF file and class packs for you guys today. Have a good day. Thank you.